In this regression example, we are going to use this ELA data file. In this SPSS task, we are asked to look at the correlations of several different test variables. So we're going to start with our correlations by going to correlate bivariate, and we're going to run a series of correlations. The first one is asking us to correlate the October and November tests. And we click OK. And for number 1 in correlations, you can see the correlation is 0.7515 and the p-value is 0.000. Sometimes we also state that as p is less than 0.001. Then we're going to run our next correlation, which is asking us to compare October and April. So we're going to move April over. And for October and April, we get our R is equal, or our correlation is 0.713, p-value of 0.000. Again, both of these have statistically significant correlations. And then we're going to click Analyze and complete our third correlation, which is going to be how the November and April tests correlate. So we're going to move October back over here and select November. And you can see our final correlation here, 0.766 with the p-value of 0.000. So the final correlation question asks us which one would be a better predictor for the April test. So what we can do is compare those correlations for the April test. We had the October and April with a correlation of 0.713, and then we had the April and November tests, 0.766. So the correlation that is higher would be the better predictor. The next series of questions has you calculate some items by hand, but we can also check those as we use SPSS. These questions are about predicting the April scores. So now that we know November has a higher correlation with the April scores, we can then check to see what the regression equation can tell us. So the dependent variable is the outcome, and we're trying to predict the April scores. That is our outcome variable. Our predictor, our independent variable, is going to be the November test. We can go to statistics, and we want to make sure estimates, model fit, and descriptives are checked, and that will help us check some of our answers for the following questions. So here you can see the mean and standard deviations listed. We have already calculated the R, or the correlation, but here it is again with the p-value. So we know it's statistically significant. And we also know that the correlation and R, those are the same thing. So we see it again here. And the R squared is also listed, which is the coefficient of determination. And you can also square R or multiply R times itself to get this value. Question 2.5 asks you to calculate the slope, or B, by hand. So you can do that, and you can also check your answer is listed here. The next question asks you to write your regression formula. So again, the regression formula, you have B, which you can plug in. You're going to also use the means that were in the table above for the independent and dependent variable and fill in the equation by hand. And you can check your calculation for A will be this number here. There was a slight difference in my hand calculation, which is just due to the number of decimal points that SPSS calculates versus the number that I calculated by hand. So you should be able to complete the regression equation with the information that is in your table on the solutions page. So you could see here, you can compare your answers here. So you can see on the SPSS output numbers that correspond to your hand calculations on this example. This is the intercept. Here is our unstandardized slope. The correlation coefficient is our standardized slope. The coefficient of determination is R squared, which is the percentage of variation in the April test that you can explain with the November test score. So you convert this into a percentage by moving the decimal point over 2 places, which gives you 58.7%. And then you subtract that from 100% to get the variation in the April test score that we cannot explain with the November test score. It's the difference between the two. And the final question, 3.3, a child that was a standard deviation higher than the mean in the April or in the November test will be expected to be how much of a standard deviation higher than the mean in the April test is this standardized coefficient here refers to how many standard deviations a dependent variable will change per standard deviation increase in the predictor variable. So this example can show you how to relate the output in SPSS to the SPSS task.